Okay, so here we're going to do a quick little refresher of the sine law. So first thing, let's just review what the sine law actually says. So the sine law says that for any triangle, the ratios of each angle, so in this case angle A, to its opposite side is equal for all three angles. So the sine of angle A over its opposite side is equal to the sine of angle B over its opposite side, which is equal to the sine of angle C over its opposite side. So it might look a little confusing at first, but it's actually quite simple and it's quite useful. So let's just look at a quick example. Yeah, here we go. So you're going to use the sine law when you do not have a right angle triangle. So if you're dealing with a triangle that is not a right angle triangle, good chance you're going to be using the sine law. And the trick is, in order to use the sine law, you must know at least one pairing. So you must know one angle and its opposite side. If you don't have that information, then you're not going to be able to use the sine law. So first step, look at your triangle, see if you have a pairing. In this case we do. We know that angle A is equal to 62 degrees, so the sine of 62 degrees over its opposite side, which is 15, is going to be equal to, we're going to choose our pairing here, in which we are asked to find angle B. So we're going to have the sine of 38 degrees over side B. It's very important that you need to make sure that in your ratios, your numerator contains both angles and your denominator contains both the sides. It's not so much important that the angles are in the numerator, but it's important that both angles are both in the numerator or both in the denominator. That might sound a little confusing, but what I'm saying is that we could also solve this problem by doing 15 over the sine of 62 degrees equals B over the sine of 38 degrees. Both of these setups here will work just fine, but what's important is that both sides are on the top and both angles are on the bottom, or both angles are on the top and both sides are on the bottom. Okay. So moving along, let's use this fellow here to solve our problem. So we have one unknown. We just want to find what angle B, what side B is, and we're given, we know two angles and one side. So from here, all we gotta do is just simply rearrange to solve for B. So here we're gonna move sine 38 over. So we're gonna isolate B by itself. So we get B equals the sine of 38 degrees times 15 over the sine of 62 degrees. Open up our nice little calculator, so we're going to get B equals, clear that guy out, we're going to do 15 divided by 62 sine equals, so I get 16.98. That is giving me the value of 15 over 62 degrees. Now I'm going to multiply this value by sine 38. So multiplied by 38 sine equals, I'm getting 10.5. So side B is equal to 10.5. Let's do one more example. So again, this triangle, it's not a right angle triangle, so we can't use our basic trig ratios. We need to look and see, do we have a matching pair? Yes, we do. We know angle B is 48 degrees, and we know that its opposite side is 17. So I'm going to write sine of 48 degrees over its opposite side, 17, is going to be equal to, we're asked to find angle theta, and we know its opposite side. So remember, we need to make sure that we have our angles both in the top in this case. So we get sine of theta, it's the unknown angle, over 21. Same idea here. We're going to rearrange to get sine theta on its own. So sine theta equals 21 times the sine of 48 degrees over 17. Remember, we are trying to find an unknown angle here, so we're going to be using sine inverse. So we get theta equals the sine inverse of everything in here. So 21 times sine of 48 degrees over 17. That might seem kind of confusing and pretty messy, but it is helpful to avoid writing the decimals along the way because you're going to end up having rounding error. But you can see, if you get comfortable with your calculator, that solving something like this is actually not that complicated. So I'm going to do 48 sine divided by 17 equals, and multiply that by 21 times 21 equals, then find the sine inverse of that. 66.6 degrees. So theta equals 66.6 degrees. That's it. Done. So that's the sine law. It's actually quite useful because it's really not that complicated. Key is to make sure that you're able to use the sine law. You're able to recognize when you can use it. It's important that you have a pair of sides, so you have a given angle and its opposite side. That's very important. If you don't have that, you're not able to use the sine law, and chances are you're going to move along to the cosine law, which you'll see is a little bit more complicated. That's it. Thanks again. See ya.